Happy morning, students. Last class, we have discussed about electronic configuration, how to we are drawing about the electronic configuration of the atoms. There are three rules of formed by the electronic configurations. The first rule is there are present in the maximum number of electrons in the shells. The second one is stepwise manners is increasing order of energy. Third one is shell of an atom cannot have more than 8 electrons. So we have seen about some examples of the electronic configuration and the geometric representation of the atomic structure of the element hydrogen, etc. Next one is valence electrons. How many electrons are present in the outermost shells? That is called valence electrons. That is also known as valence shells. Next one is valency. So some of the first 20 periodic table elements are seen in the tabular column and atomic structure of the elements. So today we are going to see about isotopes. So isotopes means that same atomic number but different mass number and same element. So isotopes means that same element, same atomic number but different mass number. For example, hydrogen. First one is 1. Atomic number is 1. Mass number is 1. That is called protium. Next one is atomic number is 1. Mass number is 2. Same atom, hydrogen atom, but mass number is different. This means that is called deuterium. Next one is tritium. Atomic number is 1, mass number is 3. Same hydrogen atom but different mass number. That is called isotopes. So same element, same atomic number, but different mass number. That is called isotopes. For example, hydrogen atom, protium, deuterium, tritium. The another examples of carbon, 6 carbon 12, 6 carbon 13. Next one is chlorine, 17 chlorine 35, 17 chlorine 37. These are the examples of the isotopes. There are two types of isotopes, stable and unstable. Which elements are stable? That of extra neutrons in their nucleus are radioactive. That is radioisotopes. Which one is unstable? Which element is unstable? That is extra electrons. Extra neutrons. Extra neutrons in their nuclei are radioactive. That is called radioisotopes. Radioisotopes. For example, cobalt-60 are used in the radiotherapy treatment. and uranium is also used in the nuclear reactors. The next one is isobars. The next one is isobars. The isobars atoms of the different elements, different elements, different atomic numbers, but same mass number. Isotopes is the same element, same atomic number, but different mass number. But isobars is the different element, different atomic number, but same mass number. That is isobars. For example, argon 1840, calcium 2040. Atomic number is different, element is also different, but the mass number means A 40 40. So this is the isotopes. These are the atomic structure of the element. Argon is 18 proton and 22 neutron. Atomic number is 18. So first shell, K shell is 2 electrons. Next shell is L shell is maximum electrons is 8. So 8. 8 plus 2, 10. Balance 8. So outermost shell 8 is filled. So the balance is 0. So this is the atomic structure of the argon atom. Next one is the calcium. Calcium. There are atomic number is 20. So the K shell is contains 2 electrons. The next L shell is contains 8 electrons. 8 plus 2, 10 power, balance 10. So L, K, L, M shell contains 8 electrons. Balance 2 electrons is the outermost shell, that is N shell. So this is the atomic structure of the calcium atom. So isobars means that atoms of different elements, different atomic number, but same mass number, that is isobars. Atoms of a different element, different atomic number, but have the same mass number, that is isobars. The next one is isotones. Isotones. Isotones means different elements, different atomic number, different mass number, but same number of neutrons. That is isotones. For example, boron and carbon. There are 5 boron atom contains 5 protons, 6 neutrons. The mass number is 11, atomic number is 5. So carbon atom is 6 protons, 6 neutrons, atomic number is 6, mass number is 12. Same element, different element, boron, carbon. There are different element and mass number and atomic number. They are also different. Protons, it is also a different, but neutron, these are the same. So the neutrons is same, that is called isotones. Different element, different atomic number, different mass number, but same number of neutrons, that is called isotones. Boron, this is the boron and carbon, this is the atomic structure of atoms. There are boron atom contains boron atom atomic number is 5. So K shell contains 2, 5 minus 2, balance 3. So outermost shell L shell contains 3 atoms, 3 electrons. So this is the atomic structure of the boron. The carbon totally, the mass atomic number is 6. Atomic number is 6. So this is the wrong. Your book printer is wrong. 2 electrons contains K shell. Balance 6 minus 2, balance 4. 4 electrons contains L shell. So balance 2 electrons there are given. So you have correct the mistake. So isotones means that different element, different atomic number, different mass number, but same neutron. Different elements, different atomic number, different mass number, but same neutrons. That is called isotones. So there are examples of the isotones. Now let's see about law of chemical combinations. In 17th century, scientists are eagerly and trying to coming to one substance to another substance. So made the certain law of chemical combinations. That is, the first one is law of conservation of mass. Law of conservation of mass. Second one is law of constant proportions. Third one is law of multiple proportions. Fourth one is law of reciprocal proportions. Fifth one is Gay-Lussac's law of gaseous volumes. The 5 laws of scientists have made. The first 2 laws are already we have studied about the lower classes. So balance 3 we have discussed about in this class. The first one is law of multiple proportions. When one element coming to the another element and form to a more than one compound, that is law of multiple proportions. So one element coming to another element to form the more than one compound, that is called law of multiple proportions. This law proposed by 1804. This law proposed by 1804. So proposed by John Dalton. John Dalton. This law proposed by the John Dalton in 1804. For example, the carbon and oxygen combine to form a carbon monoxide and carbon dioxide. So carbon and oxygen, 2 elements, this coming to form compound, that is carbon monoxide and carbon dioxide. But the mass of the one element fixed, the mass of the other elements required to form the 2 compounds are in the ratio of small whole numbers. So the ratio of the carbon dioxide and carbon monoxide is 1:2. The mass of the carbon is fixed. One is to two, but form is a two compound, carbon monoxide and carbon dioxide. The another example is sulfur and oxygen coming to form a sulfur dioxide and sulfur trioxide, but the mass of the sulfur is same, 2:3. So, law of multiple proportions proposed by John Dalton in 1804, when two elements A and B coming to form more than one compound, that is law of reciprocal pro- law of multiple proportions. The next one is law of reciprocal proportion. Law of reciprocal proportion. One of the basic laws of a chemical combination called law of reciprocal proportions. If two different elements combine separately with a fixed mass of a third element, the masses of the element exist as a simple whole number ratio. So, two different elements combine separately with a fixed mass of a third element. That is law of reciprocal proportions. This law is proposed by Jeremias Richter in 1792. This law is proposed by Jeremias Richter in 1792. For one example is given to the this is the example of law of reciprocal proportions. Here, hydrogen and oxygen. Hydrogen and oxygen combine to carbon and form a methane and carbon dioxide. Two different elements combine to a same fixed mass, that is, for example, hydrogen and oxygen, two different elements to combine fixed mass of the third element, that is carbon, to form a compound element, that is methane, CH4 and carbon dioxide. So this is the example of the law of reciprocal proportion. And also carbon and hydrogen combine to oxygen to form water and carbon dioxide. Two different elements combine to same mass of the fixed mass of the third element. So carbon and hydrogen to combine oxygen form hydrogen and oxygen combine water and carbon and oxygen combine carbon dioxide. The next one is K. Rousseau's law of combining volumes. That is, gases react together, the volumes of the reacting gases as well as the product bear a simple whole number ratio provided all the volumes are measured under similar conditions of the temperature and pressure. For example, one volume of hydrogen and one volume of hydrogen and one volume of oxygen is combined to form a two volume of water vapor. So two volume of hydrogen and one volume of oxygen to combine and form a two volumes of vapor, water vapor. This is experimentally observed and proved that the law. This is the K-Lusa's law of combining volumes. The next one is quantum numbers. Quantum numbers. The quantum numbers helps is uniquely identify an electron in the atom. So identify an electron in the atoms. So quantum number helps to identify an electron in the atom. Just like the information on our school ID card. Information on a school ID card help uniquely identify answer. But to uniquely identify a child, we can't start straight from his name or surname. We will have to start from his class. Similarly, to identify an electron, we start from N or the shell it is present it. So quantum numbers are identify an electron in the atoms. For to start with the shells or it present it. There are the four types of quantum numbers. First one is principal quantum number, Harimuthal quantum number, magnetic quantum number. Fourth one is spin quantum numbers. These symbols are the principal quantum number is N, Harimuthal quantum number is L, magnetic quantum number is M, spin quantum number is S. Same for the how to we are call them shells K, L, M, N. Same for the quantum numbers. The types of quantum numbers are symbol is N, L, M, S. The principal quantum number is make energy levels to give informations. The Harimuthal quantum number is shape of the particles. How to the atomic structure of the shells or shell shapes is formed. So this information is given to the Harimuthal quantum numbers. Next, magnetic quantum numbers, orientation of the orbitals, spin quantum number, spin of the electrons, how the electrons are revolve around the nucleus. So these are the four types of quantum numbers. So you will go to higher studies. You study about BSc physics, chemistry. So you deeply study about these papers. So in this class we have discussed about what is isotopes, isobars, isotones, and the laws of chemical combinations. Isotopes means that same element, same atomic number, but different mass number. That is isotopes. Isobars means that different element, different atomic number, but same mass number. That is isobars. Isotones means that different atomic number, different mass number, different element, but same number of neutrons. That is isotones. There are 5 laws of chemical combinations: law of conservation of mass, law of constant proportions, law of multiple proportions, law of reciprocal proportions, K-Lusa's law of gaseous volumes. The first 2 laws of we are already studied about the lower classes. So 3 laws are we studied about in this class. So unit 11 atomic structure is over. Any doubt? Ask me to clarify the doubt. So we have discussed about unit 1 measurement. Next unit 10, matter around us. Next unit 11, atomic structures. These topics are over. Any doubt? Ask me. Thank you.